Okay, so I'm just going to talk you through the atom and atomic structure. First of all, you'll see an image at the top left hand that I've put together, and this is the typical model that you'll see of the atom. And we need to be able to label it, and you guys need to know how which subatomic particle is which and where they are positioned within the atom itself. So it's going to work from the top here. As you'll see, I've drawn this out. There's the central part here. And within that, we have two different subatomic particles. Now, the first one I'm just going to write in for you, and that there is our neutron. Now, as you'll see from the image itself in the centre, where I've got that circle for the neutron, there is nothing within that inside it. There's no charge. And the reason for that is that neutrons have a neutral charge of 0. And we're going to come on to that in a bit more detail in a moment. Now, in the centre there as well, it's not just the neutrons, and you'll see that there's a plus within that, and that is for our positive subatomic particle, which is our proton. Okay, so within that central part, we have protons and we have neutrons. Now, that central part does have a name, and as you can see on the left-hand side here, that is called the nucleus. Okay, so the nucleus contains our protons and our neutrons in the centre of the atom. That's where most of the mass is concentrated. And then on the outside, orbiting our nucleus, we have our electrons. Okay, and as you can see from the symbol within them, they have a negative charge. Okay, now what you do need to know about the atom, as you can see here, two different values. So the radius of the atom and the radius of the nucleus. Now, what you need to be aware of this is which one is bigger, which one is smaller. And it may sound very straightforward to you, and I hope it does. But it's just that you need to be very clear that you know that the radius of the atom, which is this value here at the top, 1 times 10 to the minus 10, or 0.1 nanometers, is the larger of the two numbers. And then if we go down slightly smaller and we zoom into the center of the atom, that radius of the nucleus is 1 times 10 to the minus 14. Okay, and the key thing to know is that the radius of the nucleus is obviously smaller than the radius of the atom overall. Now, as I say, that might sound very straightforward to you, and I hope it does, but you just need to have those values clear in your head. Moving down, we need to be able to say where these different subatomic particles are positioned within the atom, and we've got that on this left-hand column here. But we also need to be able to talk about the mass and the charges, and this does frequently come up in exam questions. So first of all, we're just going to go through the charges because we've already touched upon those earlier in what we've just discussed in the diagram above. So the protons, beginning with P, are the positive subatomic particles. So they have a positive charge, and we need to give that a value, and this value is positive 1. So a proton has a positive charge, and that has a value of plus 1. Now, if you look at the diagram on the right-hand side that you'll see here, you'll notice that we've got 2 protons, and we've also got 2 electrons around the outside. Okay, now with that, our protons and our electrons always cancel each other out within an element and within an atom. And the reason for that is that there is no overall charge. So if we have 2 protons, we also have to have 2 electrons. So that means the charge of a proton and the charge of the electron are the same. So an electron has a charge of minus 1. Now, as I said earlier on when I went through the diagram above, the neutron actually has no charge at all, and that's why we call it, and that's why it's known as the neutron, because it is neutral, has a neutral charge, so we give that a value of 0. Now, the central column, as you can see here, is talking about mass. So just to make this very, very clear, and so everyone's understanding where we get this mass from. So the central part, as we've already discussed, is our nucleus, and that is where the vast majority of the mass of the atom is. Okay, so the mass of the atom is centralized in that nucleus, and that is for our protons and our neutrons. Now, if you look here, what I've drawn here, this diagram, is actually a diagram of helium. So you would see that on the periodic table as 4He2. Now, the top number here, which we're going to go into in a bit more detail in a moment, but this top number here is our mass number, where the majority of our mass is, and as you can see, that is a number 4. Now, if you look at the diagram below, you'll notice that there are 4 subatomic particles in that central nucleus, 2 protons and 2 neutrons. And that's where we get this idea of how much mass a proton has and how much mass a neutron has. Because actually, there's 4 subatomic particles, the mass number is 4, that means that they have a value of 1 each. So a proton has a mass of 1, and a neutron has a mass of 1. Now that doesn't necessarily mean one, like it's not 1 gram, 1 kilogram, or it's an arbitrary unit to symbolise that protons and neutrons have the same mass. And then when we go a little bit lower, electrons, you can't get away with saying that they have no mass because they are matter, so therefore they do have some mass, but the mass is incredibly small. So there's a word that you can use here, which is negligible, which means there is something, but it's very, very small. Okay, very, very small. It doesn't impact the overall mass of the atom itself. So negligible, or a value can be 0.0005. Okay. So that's, again, very important to know. That does tend to come up quite frequently in exams, so please be clear on that. And just finally, the last little bit for us to understand. Now, here is the AQA periodic table of elements that you will get given to you in the exam. You'll notice that I've put a staircase along this periodic table. I always advise my students to do that straight away whenever they see their periodic table. And what that separates is your metals on the left-hand side and underneath the staircase, and your non-metals on the right. So it just keeps that nice and clear. So what we've said above, our mass number is our central nucleus, okay, and that is composed of two things, and that is our protons and our neutrons. So if we add those together, that will give us our mass number. Now underneath that, so the example I gave you earlier was of that helium, where it's 4He2. So just draw that down here to remind you, 4He2. We had our protons and our neutrons, which is our mass number, and then underneath that we have our atomic number. So the atomic number also is known as the proton number, and it's very straightforward. The reason for that is because the atomic number is the number of protons. Really important to have that clear. So the proton number tells you what the element is. Okay, so if there are 3 protons in an atom, it's lithium. If there are 4 protons in an atom, it's beryllium. So it's very, very important to know that. However, whatever the number of protons is, tells you the number of tells you what that element is. Okay, so very important to remember that. And as we said earlier on, protons that are positive are always same as the number of electrons, okay, that are negative. They cancel each other out to give us that overall neutral charge. So you need to be able to break down the protons, electrons, and neutrons for any element. So I'm just going to give you a couple of examples here, just to make this clear. So the first one I'll talk through, you need to know really these for the first 20 elements. You need to be able to do this for all the way up to calcium, which I'll just highlight here. I'll highlight here for you. You need to be able to go from hydrogen all the way along to calcium. So first one we'll choose, we'll just look at lithium, which is here. I'll highlight that one again for you. I do apologise. There we go. Just going to look at lithium. So you'll see the bottom number, that atomic number, is 3. So that tells us that we have 3 protons. So we're just going to pop that in here. Now, following the rules we've just discussed, if you've got 3 protons, which are positive, then you have to have the same amount of negatives, which are the electrons, so you will also have 3 electrons. Now, to work out the number of neutrons is very straightforward. As you'll see from what I've got up here on the top right-hand corner, we've already said the protons and neutrons are the mass number and the atomic number are the protons. So if we subtract the proton number from the mass number, what it leaves us behind is the number of neutrons. So in the case of lithium here, for example, we've got 7 and 3. So our mass number is 7 and our atomic number is 3. We do 7 minus 3 to give us 4 neutrons. Okay, and that was for lithium. And just do one more for you, just to make that nice and clear. So sodium we will use, okay, so again I'll highlight that for you. So sodium is just here over in group 1. And if we go through that once more, so we've put our pen down, so P-E-N. And the same rules apply, exactly the same as previous. So proton number, the atomic number is 11, so we have 11 protons. Protons are positive, electrons are negative, they cancel each other out, so you have to have 11 electrons. And then finally it's the top number, our mass number, minus our atomic number to give us our number of neutrons. So that is 23 minus 11, giving us 12 neutrons. Hope that all makes sense. If you've got any questions, please pop them in the comments below and I will do my best to answer those for you. Good luck. Thank you.